Thank you, Scott. Hello, everybody. Complete pleasure to be here with you. We've got a lot to share from our side, both from a capabilities, PowerPoint description, what we're doing, but also showing you the product itself. So, half of the time we're going to spend over the next half an hour or so is going to be looking at some concepts. The other half is going to be diving right into this notion of precryption, eliminating visibility when it comes to network traffic, communications in any kind of organization, whether it's on premises, the applications are hybrid, multi cloud, container, node to node. The notion here is to make your tools, your security tools, your monitoring tools, your troubleshooting tools, much more effective with this capability that Gigamon we have to tell you all about. So the three topics today I wanted to cover in depth and hopefully be able to convince you that today we've got this huge blind spot, which is virtual encrypted lateral traffic. That's a mouthful, but basically it just implies traffic that's not crossing any kind of firewall. That's a blind spot from a security perspective, is because that is not being accessed, that is not being inspected. Um, I have this picture of this street light here, the street lamp. That's an old adage that people that lose their keys tend to focus only where the light shines. So it's the drunk that lost their key. Policeman comes up saying, what are you looking for? Looking for my keys. Where'd you lose it? I lost it over there. Why are you searching here? It's because the light's shining here. That's kind of what we do today from a security perspective, but also troubleshooting, application optimization perspective. So Gigamon, a few weeks ago, for the first time ever, launched a technology called Precryption, which allows our customers to be able to get visibility into encrypted virtual traffic no matter the environment. I'm going to dive deeper into that. And what this does, along with not just the traffic access, but extraction of metadata from that traffic, makes the existing tool set, whether it's security tools, monitoring, observability tools, much more effective. So I'm just making that statement now. We will be backing that up with actual demo in just a minute. So before we jump into this precryption capability, jump into demos, I want to roll the clock back. Roll the clock back probably 2 decades, maybe. For anybody with a networking background, this is either bringing back memories or bring twitches into bad memories. But typical infrastructure, network infrastructure, a number of tools that need access to all of the traffic on that network infrastructure for them to do their jobs for security purposes, troubleshooting, application monitoring, infrastructure monitoring, network monitoring, and so on. The challenge that 100% of our customers face is the fact that that traffic is hard to access and the network infrastructure changes all the time. And as a result, you end up getting blind spots where not all tools have access to all traffic. Plus, you end up getting a spaghetti wire of hard coded taps and span port access from tools to get the data. So Gigamon came along almost exactly 20 years ago in a few weeks or a couple of months from now. And we came in 2004. We said, hey, let's solve this problem. Let's have a box that accesses the traffic one time and centralize it, aggregates in one place so that you can have any tool that you want to deploy have a single place that they go to access the traffic. This is a classic tap and ag functionality, tapping and aggregating the traffic. Now, we've come a long way since 2004, and let's talk about some of the newer things. But before I jump into the newest thing, once we've aggregated traffic, there are over a dozen different what we call gigasmart functions that you can run to optimize the traffic, to streamline the traffic, make sure each tool is only seeing the traffic that that tool needs to see. Why do that? You do that for two purposes. One, by improving the signal to noise ratio, our customers typically see 60% drop in noise coming to the tools of traffic that's not relevant, duplicate packets, protocols that it just doesn't look at, maybe full stream of packets that it may not care about. So it makes the tools much more effective. And the other point is that the tools now have one place to go to access all traffic. So rather than sending your tools to fetch the data, you're able to send the data directly to the tools in a very, very optimized fashion. It allows you to deploy tools much, much faster, run side-by-side POCs in a very fair and quick way, and so on. Lots of different benefits. Oh yeah, so let's jump into a demo. So I have these little demo icons that pop up. So let's dive right in. This is our user interface. We can come in here, and what I'm going to do is very quickly show in a AWS environment. By the way, this is a single interface for all cloud environment. Traffic coming in. So over here, we have traffic that's coming in. On the right here, we have multiple tools that we're able to send the traffic to. So if you have a new destination, I simply drag and drop that off, and I set up the destination tunnel, and boom, all the traffic goes to the tunnel. This item on the left-hand side, make sure that all of the traffic is coming in, so you can choose what traffic you want to send to which tool. But rather than just sending the traffic raw, what I might choose to do is, you know what? Let's add some deduplication functionality. So I'll grab the traffic, I'll deduplicate the traffic before I send it off to my tool. Or in this case, I'm masking the traffic to take out privacy-related information. I can extract out application intelligence, which I'll dive deeper into. So there are over a dozen different functions that allows our customers to be able to optimize the traffic that's being sent to tools in a really simple way. So it does two things. One is optimize. The other thing is make sure that all blind spots are eliminated. So what we do based on what we call the Universal Cloud tab, which I'll also talk about in just a minute, is to make sure that traffic is being accessed as easily as possible and being sent over to your tool so that our customers don't have to worry about learning the local access mechanism, with whether it's VPC mirroring, packet mirroring technologies. Azure doesn't really have anything yet. They point to Gigamon. So for public clouds and also on-prem, VMware, Nutanix, OpenShift, doesn't matter. We worry about accessing all of the traffic. If a new VM pops up, a new node, a new container, new pod pops up, we have what's called ATS, automatic target selection, and we will find that VM that just popped up and automatically grab the traffic and send it into this picture. So that's the first demo snippet. Hopefully that was helpful in understanding traffic coming in, a single place, single UI, any number of tools you're sending the traffic to in an optimized fashion. Okay, pause. Next topic is about a real challenge. This kind of goes into where the light is shining. So what's happening now is there's an increasing amount of virtual east-west traffic just in general in the industry. Why is that happening? It's happening because what we find with our customer base over the past 2 decades is a decentralization of application development from a centralized function to something that's more with the different business units. So one of our very large banks, for example, have a business unit that's a retail banking business unit. They built their own retail banking app on the phone, which happens to be my bank, and they kind of ran off on their own. And dev teams are running very fast, and yet the threat actors tend to take advantage. Oops, I forgot to do the click through. Let me just go ahead and do the click through. Take advantage of the fact that the dev teams are running fast. They're not always careful with security. They're not always careful, particularly when it comes to networking and networking security and networking monitoring capabilities. And threat actors are taking advantage of that. So if you look up the most modern ransomware out there, for example, you're going to find that lateral virtual encrypted communications is the central function. It's what allows the threat actors to function in their lateral propagation, in their data exfiltration, in setting up the launch point, the storage point before they do the exfiltration. So this is a big blind spot out there right now. And that's what Gigamon's Precryption is meant to support. There's three parts to that. One is Precryption. It's accessing the traffic itself. The second part is Universal Cloud Tap, which is one tapping mechanism that taps traffic in a really clean way. Go into that. It's not an agent like an EDR agent. It's much more lightweight than that. And once we've tapped the traffic, some tools like a NDR can accept that kind of a pure raw traffic and cleaned up traffic, and we'll do that. We'll send it to the tool. But also, there are a lot of tools out there, such as a SIM, such as an observability tool, that cannot ingest packets directly. And for those cases, we will extract out intelligence from the traffic and be able to send that over. So that's accessing the traffic. Encryption is the other big area where most of the traffic today is encrypted, whether it's north-south, very high amount of traffic, but also east-west, also lateral communication. So if you're a hospital and you've got a client app that's talking to a server part that's going over multiple tiers, or any industry that you might be in, there's a very good chance your developers are not sending that medical record or the PCI information or whatever it might be over clear channel, over clear text. There's a very good chance they're encrypting traffic before they put on the wire. And as a result, most of the traffic is encrypted, but the bad guys are also using that same encryption technology to do their work. And this is where the tools that you have, an NDR, a firewall, and IDS, IPS, whatever it might be, really needs to see the traffic in a decrypted fashion, and that's what Precryption is meant to solve. So, decrypting virtual, public cloud, private cloud, doesn't matter. Virtual traffic, decrypting container traffic, it's not an easy task, and I'll talk about why, but that is one of the main reasons why this is such a blind spot. This is why most organizations will say, you know what, I'm not going to worry about east west. I'm only going to watch traffic once it crosses a firewall. But there's a lot of east west lateral communications that happen within virtual environment that does not cross a firewall. And you can't micro segment away and add firewalls, for example, your blind spot. So no matter how many microsegments you have, our customers will find that they do still have blind spots. So Precryption, it's a technology that allows our customers to be able to access the traffic before it gets encrypted within that virtual environment. And that's the really cool part, which is the ability to grab the traffic before it's encrypted, and then the process will still encrypt it. The communication still happens. So Gigamon does not get in the way, but it simply asks the operating system to send a copy of the traffic before it's encrypted. And there's a cool way, there's a patent technology that we have applied that allows our customers, again, to access any kind of traffic, whether it's VMs, containers, virtual traffic, before it's encrypted. And by grabbing it before it's encrypted, our customers don't have to worry about managing keys, which is a huge pain. And that's one of the big obstacles and why traffic is not being inspected. It doesn't matter what the version of encryption is. You could use TLS 1.3, you could use PFS, Perfect Forward Secrecy. It doesn't matter because we're grabbing the traffic beforehand and sending it in a secure way to the tools that need to inspect that traffic. So the way we do this is a super secret part, this is the innovation part, is by listening in or on having the OS tell us that there was a call made to this encryption library, and here's the traffic that's being sent to that encryption library. So in concept, there's technology called eBPF, Enhanced Berkeley Packet Filtering, eBPF, Berkeley Packet Filtering, and that eBPF infrastructure is part of any Linux OS. It's designed to be told what to do, with these different processes that are happening. So we come in, we ask it to send us a copy of the traffic. So it's really important to know we're not sitting in the path of the application talking to the client, talking to server, for example. We're getting a copy of it. So we're not getting in the way, which is really, really key. Okay, so let's jump into a demo of what this Precryption looks like. Now, it's a pretty complex process if you think about it. There are a lot of steps involved, but you're going to find that doing this in our product is super straightforward. So if I come in here, This is what we looked at earlier. Now I'm sending masked data. So because we're applying Precryption, we have clear text data. Our customers may want to mask out PII related information. Might want to mask out anything that's related to healthcare type of information. So if I come over here, there's a button here called Precryption. There's option here Precryption, and that's all that's needed. Is I simply take it from non-precryption to say, now that I've already deployed our UCT, Universal Cloud Tab, I can just say turn that on, and boom, all of a sudden now Gigamon reprograms eBPF to say actually it's not called reprogram, it's reconfigures. It's a function of eBPF, tells eBPF to start sending us the traffic. So coming back to the PowerPoint version, so what we have seen just now is the ability for your tools to see the data in a clear text form with all of the right masking and PII masking out steps involved in that. So what does that look like from a deployment perspective? So you've got VM that's running Gigamon, and Gigamon, there's 4 basic functions. We access the traffic, we'll optimize it, we'll transform it, we'll broker it out to the different tools for packets, or we'll send metadata to whichever tools can handle the metadata. So what we've done here is by simply doing that checkbox, we are now intercepting, or not intercepting, we're collecting, the OS is sending us a copy of the traffic before it hits the encryption library. And over a secure tunnel, we're sending that over to the tools after going through the Gigamon processing that's needed. So in essence, what this allows our customers to do is get full visibility into encrypted virtual traffic that's laterally moving, that's not crossing a firewall, without putting a whole lot of load for decryption, because that's very resource intensive, without worrying about key management, because that's very complex, and supporting any version of encryption all the way up to TLS 1.3, even MTLS, if there are any people on the call from a government perspective. So what does this actually look like? And this is actually the demo that I've just given, which is basically the functions that we offer. So there are a number of different capabilities, what we call GigaSmart applications. So here we've got masking, we've got application intelligence, we support Geneve. You may want to do some packet slicing as well. So before I actually mask out the data, I may want to send some do some packet slicing, because some tools may not look at the entire packet, or this is advanced slicing capabilities. So some tools may only look at the first 10 packets, but not look at the rest of the packets in the flow. So next 100 packets, you can just slice that out. So a lot of different capabilities that allow our customers to optimize the data as efficiently as possible without losing visibility. We come from a very strong security background. In fact, security is one of the bigger use cases for Gigamon. We know the value of making sure that you're not just removing traffic from tools that need to see traffic. It's much more about improving the signal to noise ratio. And as a byproduct of that, you end up getting much better efficiency for the tools. Now, 100% of our customers have the goal of being a single cloud, single virtual environment. 100% of our customers have multi-cloud, hybrid cloud type of an environment. So how do you deal with having a mix of different environments? Because everyone has its own traffic access mechanisms. Each platform has its own way of scaling that up. So, either through Terraform or any kind of orchestration capability to make sure you're not missing out traffic from new workloads as they pop up. With Gigamon, you don't need to worry about that, because it's single binary that gets deployed in whatever the environment might be, that gets sent out to the different tools. So I mentioned security is one of the top use cases. So let's dive into that. So what our customers deploy Gigamon for is really about accessing all of the communications eliminating blind spots, whether it's east-west communications, some nook and cranny on premises, or encrypted traffic. So we provide full inline or out-of-band SSL decryption capability on-prem. Obviously, with this Precryption, you get all virtual decryption capability as well for top use cases. But there's lots of other use cases because we have over lots of customers doing different types of things. I'm going to cover the thwart cybercrime last. I'll come back to that. From a zero trust perspective, the foundation for zero trust is really the ability to see all of your traffic, because zero trust policies is based on what kind of communications do I have, what assets are communicating on the network, and what kind of privilege do I give to those assets. If you don't have full network visibility, if you have blind spots throughout the infrastructure, then any zero trust model cannot be effectively applied because of not having visibility into communication, not having visibility into all the assets that are talking, particularly for encrypted communications as well. And so this is where the need to inspect everything, need to be able to enumerate all assets, need to look into encrypted traffic becomes really, really critical for zero trust. So that's one use case. Another use case is for compliance. So remember, being able to decrypt traffic, that's not the end goal, that's a means to an end. Decryption is not the end goal. And the reason for that is because the end goal is to be able to inspect traffic in a clear text form factor so that your tools are much, much more effective. So if I want to inspect traffic in a clear text manner, I have a couple of choices. First one is I can do out-of-band decryption, and that works okay, but it's not going to work for perfect forward secrecy, PFS type of encrypted traffic. I can also do virtual inline decryption, but it gets pretty heavy from a deployment perspective. Your developers, your app owners are going to put up a lot of red flags, a lot of resistance in putting something inline. They're also going to do the same thing for type of decryption that relies on key sniffing technology, because it kind of breaks the whole concept of having encryption in the first place. What we find is this Precryption approach really appeals to everybody, and developers, they'll always have some kind of resistance for anything that you put into their workload, but they have much, much lower level of resistance for Precryption and universal cloud type of a technology. Just last week, I was in Atlanta, met with two very, very large companies out there, spent 2 hours with the CTO and the developer SVP of engineering. And we went deep into this technology. And even the app owner, the head of engineering, said, this is something that has a lot of value and we want to deploy this out there. So if you're in the networking realm, that's your job, or even security, this is a technology that you can actually take over to your app owners and get some really good response and really good acceptance because of what it brings to them, which is something that I'm going to show in a few minutes. So the third use case is detecting at a deeper level traffic that's coming out from that's going into your SIMs. So for example, SIMs are amazing for getting the breadth of communications by ingesting log files, right? That's what they do. But log files report is something that's kind of artificial. It's not really what's happening. What's really happening is the network communication. That's really what's taking place. So having that visibility into the ground truth, the network communications, to complement logs or to add more context to logs really makes a big difference. What do I mean by that? So let's jump into a demo of that. So here is our actually, before I get into the tool itself, let me talk a little bit about application intelligence. So application intelligence is a capability that Gigamon provides. I need to move some windows around here. That Gigamon provides that lets our customers, come over here, application intelligence, lets our customers get visibility, not just into the traffic, but into the deep packet inspections, layer 4 through layer 7 visibility into traffic. So they can say, I want to filter out my Spotify traffic from the tools. I want to filter out my Windows update files because that's viewed as relatively safe for my security tools. So that's one use case of filtering. The second big use case is for application metadata. So this is the ability through Gigamon's deep packet inspection. You now have the capability to extract out over 7,000 different metadata attributes from the traffic and be able to send that to the tools that cannot ingest packets, but it's a tool like a SIM, for example, or an observability tool. So in this case, Gigamon's doing the deep packet inspection once, and we're exporting once to an observability tool, exporting the same kind of output into an Elastic, same kind of output into a SIM, and into logarithms as well. So what is it that we're extracting out? I'll make the font a little bit bigger. So we're there, as I mentioned, over 7,000 different attributes. So there's some network-related attributes, let's say around TCP connections. So we provide 29 different attributes for TCP. We also do, web. There's many, many different ways. So, for example, HTTP access, HTTP attributes rather, to 156 of those, and you can choose what you want to extract out to your SIM or to your observability tool. So, a lot of information here. Why do that? And I'll get deeper into this, but let me just give you one quick example. So, if I look over here, I see a RTT, so round trip time under HTTP round trip time category. I also see a round trip time under TCP protocol. So, a very common scenario, an app owner calls up the network people, calls up the infrastructure people saying, all my tools say my environment's fine, but my app is running slow. It's a network fault. Network is running slow, right? That's a very common use case out there. What this allows the customer to do is get a hop by hop view into TCP round trip time and HTTP round trip time. And if they see that TCP round trip time has stayed flat, but there's a spike in HTTP round trip time, guess what? That is not a networking issue. That's an application issue. So it instantly avoids a number of cycles for phone calls or Slack messages, whatever, and it speeds up troubleshooting very significantly. So the question is, where does this all go? So we're sending this data, as I showed, you can export it out to a number of tools. And here we have the data coming into Datadog, and these are all Gigamon extracted intelligence that's coming into this. We have the same data coming into New Relic, so we're pretty Switzerland when it comes to this data. We have the same data coming into New Relic, and same data coming into Dynatrace, same data coming into Sumo Logic, same data coming into Splunk. So I'm going to switch back to my presentation. I kind of just wanted to talk about the flow a little bit here, and then I will talk about use cases in just a few minutes and what do we do with that data. So another use case here is detecting lateral movements. This is encrypted communications that's not necessarily crossing a firewall, or if it is, it's not getting the level of depth that's needed. So here we have an environment, we have a threat actor, and there's an employee laptop that's outside of the infrastructure of the corporate network, and somehow this person manages to do something that infects their machine, basically. And that machine does its thing. Then the threat actors do the usual C2 type of work that they do, communication that happens, and the machine's compromised. Then the machine gets on the network. And the threat actor does an inventory, does an admin rights, does a permissioning privilege check, and that data gets sent out. So what we see and what the tools will see is that, hey, there was a VPN login that the threat actor did. And then the lateral movement that's happening will likely not get picked up because this is happening over a virtual lateral movement that's not crossing a firewall. And it's encrypted traffic. As I mentioned, most of the traffic does not get inspected. So at that point, there could be some backdoor established from one of the machines on-prem, or it could be the employee's laptop as well. And having access to clear traffic allows these tools to see something happen. There's something going on here. I'm not going to get into this right now, but part of the demo, we show this exact scenario with Security Onion on what Security Onion's able to see on Wireshark traffic coming in that's encrypted, and then we run Precryption and we show it in Wireshark and we show it in Security Onion, and it provides a lot more visibility into the actual communication that happens in these lateral movements. So without precryption, without having visibility, without having traffic access, without having visibility into this encrypted traffic, there's a lot of communication that happens back and forth, but that's all based on. But what comes out from the tools is a much higher level of information than the level of clarity that our customers are able to get in detecting threat activity in the biggest blind spot out there. So these are security use cases. There are lots of other use cases that we can get into. And I will actually demo a few of these right now. And let's dive right into it. So this is an eye chart. I'm not going to go through these use case by use case, but these are actual use cases that our customers have deployed into their production environment. And having this outside-in view, the inside-out view being an agent that you're deploying or a syslog file that a system is generating, that's what the system is seeing. What we're seeing is something that's communicating outside that shell, outside that VM, outside that instance, that you simply will not see from an agent coming in. So actually, let me just go forward one slide. So the use cases are generally from an application perspective, and this are numerous. And this is what we find to be super effective in providing visibility into applications that's acceptable by the application owners, because they can get visibility into service level objectives that an Azure or GCP or Google, that AWS will not provide. They get correlation information across what the agent says and what the network actually reports. By correlating the two, they get some incredible visibility that they will not otherwise get. Service level mapping. So this is the notion that am I really seeing the service levels? If something goes wrong, is it happening in my environment, outside my environment? Is it a hop-to-hop latency issue? These are what we find to be super effective value props that's simply not possible without Gigamon in the pictures. I'm going to spend a few minutes on walking you through a quick demo. So I'll start off with, I mentioned service level objectives. So here we have, these are service levels on in New Relic coming in from, so the second and the last two are Gigamon data coming in. Others don't have Gigamon visibility. So an AWS, for example, I'm just not picking on AWS, I'm just using that as an example, may report that there were some bad responses based on some agents coming in. What they're not going to see are HTTP bad responses or HTTP packet drops or CRC checksum errors that's not coming into that instance, into that VM, let's say. So the example that I give is if all of us were in a room together, I can see everybody coming in and talking to somebody in that room. What I cannot see are people coming to the door and then seeing that and realizing the door is locked, or dropping packets outside the door. An agent or a syslog will not be able to see that level of information. That's why getting that outside-in information, correlating that, super important for service level objectives. Also super important for application insights. So for example, here we have TLS insights. The question is, using New Relic, are there any weak ciphers being used out there? So an app owner following OWASP might say that nobody should use TLS 1.1, everyone should use 1.2, ideally 1.3. However, they don't know if downstream from the CI/CD process, if someone's actually has a connection and that handshake degraded down to SSL version or whatever it might be, or using a weak cipher, they don't know that. Gigamon helps them ensure that this best practices is being followed. So that's just one example. There are suspicious activities, so it's something called port spoofing or non-standard port use. So, for example, I can connect over to your machine as an SSH secure shell session. It's going to default to port 22, but of course, everybody, including you, will have your port 22 blocked. But I can override that session to go over port 443, which is just web traffic, SSL traffic, and most people will not have that blocked off. So all of your logs and all of these tools, your SIM, your Splunk, your New Relic Datadog Dynatrace will all report this is SSL traffic. Don't worry about it. But because we access the traffic, we do deep packet inspection, we see that this is going over port 443. But guess what? This is not SSL traffic. This is SSH traffic that's being spoofed over 443, or this is DNS over 443, or DHCP over 443. Is that an attack for sure? Not known for sure. However, this is something that needs to be looked into. Just some use cases here. Let me do a couple more use cases, and then I will pause for questions. So slow applications. Are there widgets within the application that might be running slow? So an application typically has multiple sections. Each section is making its own DNS request, its own HTTP request. And so we'll tell you that DNS requests for all of them were good, but this one widget was slow. So this is what allows our customers to be able to figure that out. Let me see if I can pull up the correlation dashboard. Correlated. So this is a case where, by the way, I'm showing this in New Relic, but all of this is available across the board. So no matter what the tool you have, it will be able to pull the data out. So the correlation basically shows that based on this connection, this takes a little bit of time to load. I'm just going to kind of talk about it conceptually. So here we have a spike in services unavailable. So this is something that the agent is reporting to Gigamon. I'm sorry, to New Relic in this case, saying that, hey, service was unavailable. If you look at this box on the right-hand side, right around that time, there was no TCP sessions. And there was later on TCP session drops, lost packets later on. So this basically shows that this is not a TCP related issue that happened here. This is not a networking related issue. And there's many more attributes that are correlated that shows whether it was a network related issue. And this is a case where it is the average load time, where DNS responses were bad. So something is going on over there. This kind of view, simply not possible anywhere else. And I'm not saying that as an exaggeration. When we work with our partners in Dynatrace and other places, they will tell you the same as well. This is complete innovation. Again, it doesn't matter what the tool our customers use. We offer the same capability across the board. So hopefully I've covered the different use cases, albeit a little quickly. I've demoed, sorry, I've already gone through the demos. So in closing, hopefully we've made a good point or good case that encryption is a big blind spot that needs to be inspected, and that Precryption does solve that biggest challenge in accessing the traffic and being able to decrypt or provide the traffic in an unencrypted way, and not just the traffic, but the metadata as well. So the only other thing I would ask you to do is contact us. We would love to walk you through this, and I've done a very fast demo, talked about the concept, but it is something that will make an impact in security. It is something that will also help the app owners in a way that's simply not possible before. So with that, I will not cover this slide. You can read it for yourself, but I want to see if there are any questions out there.
Yeah, Bassam, great presentation. This Precryption technology is so interesting. So we do have some questions here from the audience. One is Gigamon altering the operating system to get pre-encrypted traffic?
Right. So I did stumble on that a little while ago when I was talking about it, and I had to correct myself. But I just want to. That's a great question. Thank you. I want to restate that we're not altering the operating system. All Linux environments come with a default service called eBPF, and eBPF is designed to be reconfigured or to be instructed to do exactly what we're doing. And in this case, what we're doing is saying that there's something called an OpenSSL library that almost every developer uses to encrypt the traffic before they put it on the wire. So if that OpenSSL library is being called, eBPF simply is instructed to send us a copy of that traffic that's going into OpenSSL before it's encrypted. And by the way, on the other end, if we get deployed on the server side, we ask eBPF to send us a copy after OpenSSL has decrypted the traffic. So there's no encryption, re-encryption, decryption load that Gigamon puts on the system. This is all built in to the functionality of Linux, and we so it's not reprogramming it. This is why developers really appreciate the approach, and all developers really are very familiar with eBPF, and they appreciate this approach. Good
Okay,
question.
excellent. Next one here, they're asking, how does Gigamon send network traffic to APMs and observability tools?
Great question. Let me actually jump right into it. So I showed the demo of how the data ends up in these observability tools. I showed the demo of how Gigamon is sending the traffic. You can choose which attributes you want to send. You can just select that. The process for sending that. Let me, if you don't mind, I'm just going to pull up a slide here very quickly. This will tell a good story, hopefully. So on the left-hand side, our customer's infrastructure. On the right-hand side are the observability tools. Sometimes I drew this as a cloud service, but this could also be on premises, doesn't really matter. And the dashboards, the queries, the analytics all happen from these tools based on the agent that's sending out MELT, metrics, events, logs, and traces, mostly logs, over to these tools. Gigamon says at some point these systems talk on the network. Let's grab the traffic. Let's grab all of the communications. So vSeries is our intelligence, is our product, is the core of our product. We're going to extract network related metadata and send that over to the tools in a way that the tools can understand, which is again using MELT format. So we're kind of converting network packets into a format that these tools can ingest. So you get this outside in view that allows you to build this correlated dashboards, this new visibility, not just for managed hosts, but for all hosts out there. This is actually one of the big use cases. I probably should have added it, which is IoT. So using existing Dynatrace, for example, to all of a sudden get visibility into IoT communications or Splunk or whatever else that might not be seeing the traffic. So again, the last part of the slide just builds up a whole lot of different use cases. So the way we get the data is by converting network packets, which is very low level raw traffic, high volume, you don't care about that, into something that's sort of pulling the nuggets out and sending those really important pieces of information for service level objectives, faster troubleshooting, network latencies, those types of things into the tools that app owners live in. Good question.
Okay, excellent, excellent. This next one is kind of a comment. They're saying our app owners will push back on installing agents in their workloads. Any thoughts for that person and sort of their internal
Yeah,
politics?
yeah. We see that over and over. In fact, when as I mentioned last week, I was at this meeting with the SVP of development. This person is the highest level person. And he was raising a lot of concerns coming into it about putting anything into their workload. But once we walk them through the reports that are possible, the analytics that are possible, and how our UCT product works, it's one binary that runs across the board in any kind of platform, leverages eBPF. And as soon as you mention eBPF to developers, they're like, "You're on, come on in." So we find that this has been very, very effective in sort of softening up the app owners in accepting this. In fact, what we've found, we've actually had network engineers tell us that this is my invitation, it's my invitation card to getting involved in cloud initiatives, not after it happens, but actually before it happens. So being part of the cloud projects much, much earlier, which is a big benefit for customers.
Oh, very cool. Okay. Next one here. What can Gigamon see that our firewalls can't?
Great question. So the firewalls will see traffic coming in and out of of any so physical environment. Obviously, firewalls are typically put at the edges, or sometimes east-west lateral traffic. Virtual gets a little bit more complex. So yes, you can have microsegmentation, but as I mentioned, you cannot microsegment out blind spots. At some point, there's going to be some level of lateral communication, and that's the dark area. That's a part of the unlit part of the street that bad actors operate in. So we will provide you visibility into those dark areas of the street that you will not see in traffic that's crossing a firewall. It's super important to know. As much as firewall vendors would love to sell you endless number of firewalls to put everywhere, it's going to get pretty expensive pretty quickly. It's going to add more to your load, to your performance, not just to buy the firewalls, but the cloud service provider bills, AWS, Azure, GCP bills, and running that. It's just not practical. And so that's what we bring that firewalls can't, is visibility into east-west traffic and north-south as well. I mean, that's kind of what we do, that firewalls will never see.
Okay. All right. Excellent. This next question, they saw cryptocurrency in your demo. They're
Oh yeah.
wondering if you can talk a little bit more about that.
Yeah, I didn't spend too much time on that. Thank you for noticing it. Pull this up. Thank you for noticing it. We do have over a dozen different crypto mining traffic that we can detect, which is kind of interesting with a higher level audience, with C levels. When we talk about this capability, crypto mining is something that's not easy to detect because there's no C2, there's no command and control communications, there's no known bad IP addresses. However, crypto attacks and crypto usage in public cloud is a thing. If you just Google it, you'll see that there are threat actors that come in and they will install crypto mining versus doing like a ransomware type of an attack, because that's a shorter route to revenue for them. If they start installing crypto mining, there's been some public hits on companies like Tesla a few years ago. So this is a thing, and detecting this is quite hard. So what we do is there are over a dozen different protocols that we look at. Just by simply looking at the communication protocols and patterns and traffic, we're able to identify these traffic and be able to report it out. So yeah, thanks for observing that. But that is an interesting function that's kind of unique to Gigamon, and this type of observability that you will not get with most other tools out there. Good
Okay.
question. Love
All right.
these.
Um, well, Bassam, I think that's we're kind of coming up on time here, but just sort of as a last question, if somebody wants to get started with the Precryption technology, do you have any recommendations for them?
Um, the best thing to do is contact us. So we will walk you through the technology much more at an interactive level. We are very friendly. We won't bite. We are very aware. Most of our customers are technologists, so it's not going to be a heavy sales pitch. Most people that I talk to after they've kind of come in through our front door and talk to our demo team, they walk away with a good experience and good understanding of what we do without feeling like they're sold to. So I would highly recommend just getting in touch with Gigamon and checking us out.
Okay, excellent. Well, that's a great place to leave it. Bassam, thanks for a great presentation, great demos, and all your insights here in the Q&A. Really appreciate your time today.
Great to be here. Thank you.